This is America in Space, a weekly news and information program on current events dealing with the space industry.
Welcome, and thanks for joining me today. I'm Dawn Meyer, Space Coast News Editor. Japan landed the Smart Lander for Investigating the Moon, or SLIM, craft on the surface of the Moon on January the 20th, 2024, making it the fifth country in the world to land on the lunar surface. Now, yes, there was a problem that we'll go into. However, its achievement solidifies Japan's position as a leader in space technology. SLIM experienced an engine problem during landing and was unable to deploy its solar panels, so it had to shut down to conserve energy. Here is more on SLIM and the anomaly from NASA Space News.
Japan's SLIM moonlander achieved a historic pinpoint landing on the moon, something that has never been done before. But there was a twist. SLIM landed upside down and unable to communicate with Earth. SLIM has a box-shaped body that measures 2.5 meters long, 2 meters wide, and 1.8 meters high. It weighs about 600 kilograms and has 4 main engines and 12 attitude control thrusters. It also has 4 solar panels that can produce up to 600 watts of power and a high-gain antenna that can send and receive data and images. SLIM's landing system consists of a guidance, navigation, and control, or GNC module, a laser altimeter, a laser rangefinder, and a hazard detection camera. These instruments allow SLIM to autonomously select a safe and suitable landing site, and to adjust its trajectory and attitude accordingly. SLIM's target site was a 100-meter-wide zone near the Scioli crater, which is located in the south polar region of the Moon. This region is of scientific interest because it may contain water ice and other resources that could be useful for future lunar missions. This landing system on the spacecraft was designed to achieve a landing accuracy of within 100 meters, which is much smaller than previous missions, such as Apollo, which had a landing accuracy of about 10 kilometers, or Chang'e, which had a landing accuracy of about 3 kilometers. Despite the landing mishap, SLIM still managed to hit its target zone, landing only 55 meters away from its intended site, in between 2 craters. This was a historic achievement for Japan, as it demonstrated a high-precision landing system that can target unexplored and challenging areas of the Moon. SLIM's mission is not over yet, and there is still hope that it will be able to recharge when the Moon enters its daytime in the coming days. The Moon has a day-night cycle of about 28 Earth days, and SLIM landed on the Moon on January 18, 2024, when it was near the end of its night. The lunar night is very cold, with temperatures dropping to below -150 degrees Celsius, which can affect the performance of the batteries and electronics. It also has a thermal control system that uses heaters and insulation to keep the temperature within a safe range, but it also consumes power. The batteries have a capacity of about 1.5 kilowatt hours, which is enough to operate for about 24 hours. However, SLIM's solar panels are facing the wrong direction, and they cannot receive any sunlight until the Moon rotates enough to expose them. This means that SLIM has to rely on its batteries to survive the lunar night, which lasts for about 14 Earth days. If it can power up again, it may be able to send more data and images, including high-resolution ones, that could provide more insights into the lunar environment and SLIM's performance. It also has a scientific payload that consists of a spectrometer, a magnetometer, and a seismometer that can measure the composition, magnetic field, and seismic activity of the Moon. The mission is also a valuable technology demonstration for future lunar exploration, as it shows that it is possible to land on unexplored and challenging areas of the Moon, such as mountainous regions, that may hold resources of fuel, water, and oxygen. It is also a testament to Japan's space capabilities and ambitions, and precedes its planned participation in the Artemis program and the Lunar Gateway project.
On January the 28th, 2024, SLIM phoned home. According to a report from JAXA, the Japanese Space Agency, the changing angle of the sun allowed the lander to restore power and communication, resume its scientific operations, and start transmitting new images of the lunar surface near the Scioli crater using its multi-band camera. Here is more about how communications were revived by the 2 mini robotic explorers that SLIM deployed.
Today we have a new evidence showing that the spacecraft ended up upside down on the moon's surface and unable to communicate with Earth. The image of SLIM was taken by a Lunar Excursion Vehicle 2, or LEV-2, one of the two autonomous probes that SLIM released before touchdown. LEV-2 is a small spherical robot that weighs about 1.5 kilograms and has a diameter of 15 centimeters. It is equipped with two cameras, one on the top and one on the bottom, that can capture images of the lunar surface and the sky. The main purpose of this vehicle is to explore the lunar environment and collect scientific data, such as the temperature, pressure, and magnetic field of the moon. But LEV-2 also has another important role: to communicate with SLIM and another hopping robot, LEV-1. Its main function is to relay data and images from SLIM and LEV-2 to Earth, directly, not via SLIM. However, both vehicles can communicate with each other and with SLIM using a wireless network protocol called DTN, or Delay Disruption Tolerant Networking, which is designed to cope with the challenges of interplanetary communication, such as long delays, high error rates, and intermittent connectivity. It also allows the robots to store and forward data packets until they reach their destination, without requiring a continuous link. This is how LEV-2 sent the image of SLIM to LEV-1, which then transmitted it to Earth directly. This was the world's first mission to achieve such a complex and autonomous operation on the lunar surface, and it shows the potential of using multiple robots to cooperate and explore the moon. The image of SLIM that LEV-2 took shows that SLIM is upside down on the moon, lying on its nose, with its solar panels facing the wrong direction. This means that it cannot generate power and communicate with Earth, and that it may have suffered some damage during the landing. The cause of the landing anomaly was a loss of thrust in one of SLIM's main engines in the final stages of its descent, which made it land harder than planned.
So after all of that, SLIM is being declared a success in the new lunar space race. Thank you for joining me. Listen each Tuesday for This Week in Space with John Gomez. And join me every Friday for America in Space. From the Florida Space Coast, I'm Dawn Meyer, Space Coast News Editor for About Space Today.
Thanks for listening. Be sure to share our program with your family and friends, and follow us on Facebook. Join us each week for news and information on America in Space.